Hi everyone, welcome back to DNS for SOC Analyst. In these previous videos we learned what DNS and how DNS converts domain names into IP addresses. Now in this video we are going to understand DNS cache, why DNS cache is needed, how DNS cache works, and we will also have a small introduction to DNS over HTTPS or simply DOH. And finally we'll discuss some scenario based questions related with the topic. First, let's understand what DNS cache is. DNS cache is a temporary storage where the domain name to IP address mapping are stored like a phone book. When you visit your website from the first time, your computer asks the DNS server for the IP address of that domain. For example, if you open google.com, your system asks the DNS server what is the IP address of the google.com. The DNS server responds with the IP address, and this information is stored in the local DNS cache in your operating system. Here I can put google.com in my URL and connect with DNS server. The DNS server responds with the IP address associated with the domain. Once user gets the IP address, this information is cached or stored in a local machine. When you try to expand, when you visit the same website again, your system does not go to does not contact the DNS server again. Instead, it retrieves the IP address from the local DNS cache. This reduces DNS queries and network traffic. So the main purpose of DNS cache is to improve website loading speed, reduce the load on DNS server, reduce network traffic, and improve overall network performance. Okay, let us see how DNS cache works in a scenario based. Okay, the scenario is like when a user enters a domain name in the browser, the system first checks the local DNS cache. If the record is found in the cache, the system uses the IP address. If the record is not found in the cache, the system contacts the DNS server, gets the IP address, and then stores the information in the DNS cache for further use. Okay, now let us see DNS cache practical way. I open my command prompt and I put the command ipconfig. I think now we're clear. ipconfig display DNS. It shows information stored in cache. Okay. Record name refers domain name that was queried. Record type means the type of DNS record. We will discuss about later on. TTL means how long this record will stay in the cache memory. And cache. Data length means the size of the data, and section means which part of the DNS response. Okay, and CNAME and host record we will discuss about in my upcoming lecture. Okay, now we clear the DNS cache. The command is flushdns. So successfully flush the cache. Okay, now I check again with the same command display DNS, nothing found. Okay, if you want to, so if you now we will check using the browser google.com, enter, so nothing, so the website opens here. So now we check it is stored in the cache or not. Yes, of course it's stored. Okay, sometimes it may come error, sometimes it comes with error. That time how to troubleshoot? So display, because here no information is found if I do it again. Okay, what's the reason? It means DNS servers always uses the port number 53. It is unencrypted way. So it uses DOH. It means DNS over hypertext transfer protocol secure, or DNS over HTTPS. The port number is 443. It means when it uses DOH, the queries are encrypted. So if SOC point of view, it is safe and secure. So DOH is also important in cybersecurity because attackers sometimes use DOH to hide malicious communication. Okay. Now we discussed about some of the concepts well. So let's summarize what we learned in this video. Okay. Now we retrieve the information. Here you can see display DNS. Before summarize everything, just we use one more command to make connection properly to get display DNS works. That is called ping google.com. Okay, it pings. Okay, so now we check the cache is stored or not. Okay, so cache is stored here. Okay, check the IP address is same. The response IP address is here. The DNS server IP, this host record is the same. So this is the DNS server IP. Okay, now we summarize the information discussed now. DNS cache stores domain name to IP address mapping. DNS cache improves website loading and reduces DNS traffic. We can view DNS cache using ipconfig display DNS, and we clear using flushdns. So DOH encrypts DNS queries for privacy and security. Okay, let's discuss about scenario based questions. Okay, now some scenarios will if you understand scenarios helps you to understand well the topic. So it helps to understand the topic well. Let me start it now. Okay, we are going to discuss some scenario based interview questions related to DNS cache and DNS troubleshooting from a SOC analyst perspective. These scenarios will help you understand how DNS is used in real world troubleshooting and security investigation. Okay, the scenario 1 is flush DNS fix the issue. Okay, let us look at the first scenario. A user reports that a website is not opening on their system, but the same website is accessible from other systems. After running the command ipconfig/flushdns, the website starts working. What was the issue here? Can you imagine? The issue was most likely caused by an outdated or incorrect DNS cache entry stored in the local DNS resolver cache. The system was using an old IP address stored in the cache. After flushing the DNS cache, the system queried the DNS server again and got the correct IP address. So, from a SOC or troubleshooting perspective, this could happen if the website IP address changed, the cache was corrupted, or in rare cases DNS cache poisoning. We will discuss about cache poisoning in our attacking section. Flushing DNS forces the system to perform a new DNS lookup. So now you understand the scenario 1. I believe this. And next we move on to the second scenario, suspicious domains in cache. Okay, let us look at the second scenario. While investigation a suspicious system, we run the command ipconfig/displaydns, and we notice many unknown or suspicious domain name in the DNS cache. What does this indicate? This could indicate malware infection, command and control communication or C2 communication, phishing website access, or suspicious applications running on the system. From a SOC analyst perspective, DNS cache is very useful because it shows which domains were resolved on that system, even if DNS logs are not available. DNS cache can provide evidence of domain access. In the situation, the SOC analyst should check DNS logs, check running process, check browser history, scan the system for malware, and investigate network traffic. Step by step you can do. And another scenario is nslookup works, but website now not opening. If you are a beginner, don't worry about nslookup. We are going to discuss in upcoming videos. Okay. nslookup return an IP address from your domain, but the website is not opening in the browser. What could be the issue? Can you imagine? In this case, DNS resolution is working because nslookup is able to get the IP address from the DNS server. So the issue is not DNS resolution. The issue could be browser cache, proxy setting, firewall blocking, HTTPS certificate issue, or general network connectivity issues. Okay, so the troubleshooting steps would be flushing DNS cache, clearing browser cache, checking proxy settings, checking firewall, and testing network connectivity. In our next scenario, we are going to discuss about one more investigative perspective. So, why DNS cache is important for SOC investigation? DNS cache is important because it helps analysts identify previously resolved domains on the systems. Okay, even if DNS logs are not available, DNS cache can show which domains were accessed or resolved by that system. This is very useful in incident response, malware investigation, phishing investigation, and domain activity analysis. DNS cache can provide evidence of domain resolution and help analysis under system activity. Okay. I think this video will helpful to learn DNS cache well and help for your interview preparations. Thanks for watching this video. Bye bye. We will see you in my upcoming videos.